Cos1511 Lesson 3 Variables. Purpose of this lesson. Variables provide a way to make programs more general. In this lesson, we investigate the use of integer variables to allow us to get a program to input numbers from the keyboard and work with them instead of using numbers that were coded into the program when it was written. Write a program to input two numbers from the keyboard and determine and display their quotient. The following should appear on the screen while the program is running. Enter two numbers, 23, 5. The quotient of 23 and 5 is 4. Note that the numbers 23 and 5 and the space between them are underlined to indicate that these values are entered by the user while the program is running. Test yourself. We don't expect you to be able to write this program straight away because you probably don't have the knowledge of how to do so yet. The sub-activities that follow explain the various concepts that you need to understand to be able to write this program. If you've done programming in some other language before, you probably have a fairly good idea of what you need to do, but just need to know how to do it in C++. The first sub-activity below should be enough for you to complete the activity problem. Note that your program should work correctly for any two numbers entered by the user. Subactivity 3AI. Consider the following program. // what happens? ? Hashtag include iostream using namespace std semicolon. Int main, open bracket, close brackets, open curly brackets, next line, int age, semicolon, cout, enter your age, colon, semicolon, cin, age, semicolon, cout, that's a great age to be, int l, semicolon, return 0. If you can predict what will happen when this program runs, then compile and run the program to check whether your prediction was correct. Also, try to explain the purpose of the statements int age and cin extraction age, semicolon. If you're not sure, guess. Once again, we don't give the output to encourage you to type in it and test out the program yourself. Note that the program should pause in the middle with the cursor flashing to indicate it is waiting for you, the user, to enter a number. Only after you have typed the number and pressed enter will the rest of the program be executed. Discussion. The statement int age is called a declaration statement. It declares a variable called age. A declaration statement sets aside a memory position for a value to be stored and associates a name with that memory position. We can illustrate the situation with a diagram. Age block. The box represents the memory space. We write the name of the variable above the box. The variable has a name so that we can refer to the value stored in the memory position later in the program. We decided on the name age because we intend to store a number representing an age in it. Note that a variable name has no meaning to the computer whatsoever. You could change the name age to pumpkin or whatever you like, and the program would still work perfectly. We use meaningful names so that we and others can read and understand our programs. By the way, the numbers that we used in lesson 2 are called integer literals, as opposed to integer variables that we have now learnt about. The statement cin, age, is called an input statement. It is used to obtain a value from the keyboard and store it in a variable, in this case, age. We indicate this in our variable diagram as follows: age 23. Like cout, cin is defined in the standard header file iostream. It stands for console input and is pronounced as cin. The console therefore does not refer to the screen as we said in lesson 1, but also to the keyboard. Note that we use the operator with C in opposed to the operator with C out. Programmers often make the mistake of using the wrong operator with either of them. One way to remember that is that the arrows indicate the direction of movement of data. In other words, with C out, the data moves from the program to the console, in other words, to the screen, whereas with C in, the data moves from the console, in other words, from the keyboard, to the variable in the program. Note finally that there is a space between the colon and the close quote character in the initial C out statement. This ensures that a space is displayed on the screen after the colon for the user to enter the number. You might like to see what the effect is if this space character is removed from the program. Subactivity 3AII. Note, not all names that you can choose for variables are legal. C++ has rules for what names are legal for variables and what characters may be used in them. For this subactivity, you must investigate what variable names are legal. After your investigation, you should be able to answer the following questions. Can numeric characters in any letters of the alphabet be used in a variable name, and in what order? 2. What other characters can and can't be used? 3. Are there any words that are not allowed to be used? Use a very simple program like this to do your testing. Test variable names, int main. From now on, all of the coding you can read as it carries on. So pause it and read the coding. Note that we have left out #include iostream and using namespace std. Since the program does not use C in or C out, simply change variable name each time and recompile. The answers to the questions are as follows. 1. Any combination of numeric characters and letters of the alphabet can be used, except that a name cannot start with a numeric character. The only other character that may be used in a name is the underscore character. Names may also start with underscore. Certain words like int and return can't be used. However, a variable can be declared with a name cout, cin, or nl. If you didn't investigate the names as we suggested above, why not try it now? Type in the little program and test these 3 rules to convince yourself that they are correct. Discussion. With respect to point I, note that a variable name can consist of lower or uppercase letters of the alphabet. In fact, you can make a variable all uppercase letters if you want. We generally use lowercase letters. About point 3. C++ has a number of so-called reserved words, and you may not use a reserved word for a variable name. Appendix A at the end of this guide contains a list of C++ reserved words. It is interesting to see that cout, cin, and nl are not reserved words. They are defined in the iostream header file. One might expect the compiler to complain if you declare a variable with one of these names, example int cout, and then add #include iostream and using namespace std to your program. It doesn't. It only complains when you attempt to use the variable, example cout, nl. The moral of the story is it's a bad idea to use cout, cin, or nl as variable names because it causes confusion. The opposite is also true. If you mistakenly use one of these names as if it were a variable, example cout, the compiler will not complain. You will just get unexpected results. The moral of the story is, if you get strange results, check whether you haven't made this kind of error. Change the program in subactivity 3AI slightly to produce the following output. Into your age, 29. 29 is a great age to be. Compile and run your program to see whether it works. Make sure that the number displayed at the beginning of the last line of output is the same as the number the user entered on the first line. Also add a comment line at the beginning of the program explaining what it does. Inputs agent displays it with a message include iostream using namespace std int main int age, see out, int your age, see in, age, see out, age is a great age to be, NL, return 0. Discussion. Note the following about this program. We can display the value of a variable in a cout statement. Furthermore, it can be displayed together with other strings and values of expressions in a single cout statement. Once again, we use a space character between the opening quote and the word is in the second output statement to ensure that a space is displayed between the value of the variable and is when the program runs. Subactivity 3AIV. Edit the program by removing the declaration statement. In other words, delete the line int age. Try to compile the program again. The compiler will complain about the statement cin age with the message age undeclared. Put the declaration statement back, but in a different place this time, namely between the first output cout statement and the input cin statement. Compile the program again to check whether it's okay. It should compile and run correctly. Now move the declaration just after the input statement. If you compile the program again, the compiler should give the same error message as before. To see a similar problem, move the declaration statement back to its original position at the beginning of the program and change the output statement to cout, years, is a great age to be, end L. Then try to compile the program again. This time the compiler complains that years is undeclared. Discussion. The point is that we must always declare a variable before we use it or refer to it. This may appear to be a very simple rule to follow, but often one can make quite subtle errors that are connected to this program. A common error is to misspell a variable name slightly. For example, say we declare a variable as aga instead of age. Then when we refer to age later in the program, the compiler complains that it is undeclared. We then need to go and fix the name in the declaration. Alternatively, we could change all occurrences of the variable to aga, but although that would make the compiler happy and the program would probably work correctly, it would be a less sensible thing to do. Another subtle area is changing the case of one or more letters in the name. For example, we declared a variable as your age and then referred to it later as you rage. Remember that C++ is case sensitive also for variable names. See if you can change the program to display the following output. Enter your age, 29. You'll be 30 on your next birthday. Once again, make sure that the second number is displayed is dependent on the number that is entered. Inputs age and displays age plus 1 with a message. Include IO stream using namespace std. Int main, int age, cout, enter your age, cin, age, cout. You will be age plus 1 on your birthday, end L, return 0. In this program, we see that variables and numbers can be used together in an expression. In fact, we can make things as complex as we like. We can use an integer variable anywhere in an expression where we would have used an integer literal. Now change the program to display the following output. Your mom's age and your age, 5029. Enter your mom's age and your age, 5029. Your mom was 21 years old when you were born. Calculate mother's age when you were born. Include IO stream using namespace std. Int main, int mom's age, your age, cout, into your mom's age and your age, cin, mom's age, your age, cout, your mom was. Cout, your mom was, mom's age, minus your age, when you were born, NL, return 0. Discussion. You probably use two separate declaration statements on separate lines. Example, int mom's age and int your age. This is not incorrect. We just use a shorthand notation to declare two variables in the same declaration statement, separating the two names by a comma. In fact, you can declare as many integer variables as you like in a single declaration statement. After the declaration statements, we can indicate the state of affairs with the following variable diagrams. Your mom's age, your age, 2 blocks. Note once again that we have used descriptive names for the variables. The names describe the values that are stored in the variables. When we want a variable name to consist of more than one word, we generally connect all the words together and use uppercase for the first letters of all subsequent words. This is called camel notation because the humps are in the middle. For example, we had a variable that we wanted to store the tax before profits. We could call it tax before profits. Note that camel notation is only a convention, not a syntax rule of C++. The last thing that you should note is that we can use more than one variable in an expression. In other words, mom's age minus your age. Now, you should be able to complete the main activity. Calculates and displays the quotient of two numbers. Hashtag include iostream using namespace std, int main, int m, n, cout into two numbers, cin, m, n. Cout the quotient of m and n is m divided by n, L, return 0. Discussion. Note the variable names in this program. You might think that m and n are not very descriptive names. Perhaps you think that names like numerator and denominator would have been better. Well, in this case, it's doubtful whether fancier names would contribute to the readability of the program. There is another convention that we use when declaring variables. When we declare a variable that is only meant to store a value, and the value doesn't represent specific, like an age, anything specific like an age, an amount of money, or a number of people, then we normally use a single lowercase letter of the alphabet like M or N or I, J or K. This is because a longer name doesn't add any information and can in fact clutter the code and make it less readable. Activity 3B. Change the program of the previous activity to display the following on the screen. Enter two numbers, 23, 5. The remainder of 23 divided by 5 is 3. In other words, instead of calculating and displaying the quotient, the program should calculate and display the remainder. Test yourself. We have provided two solutions to this problem. The first is given in the solution to the first subactivity below, and the other is given in the activity solution further on. You ought to be able to produce the first solution with the knowledge that you have so far. If you are unable to produce the first solution yourself, you need to go back to the previous lesson, especially exercise 2.3, and the first activity of this lesson. Make sure that you understand everything completely, then attempt this problem again. When you've written a program, compare it to the one below. Then work through the subactivity before simplifying your program and comparing it to the final activity solution. Write a program for the main activity using the solution to exercise 2.3. Calculate the remainder of one number divided by another. Hashtag include iostream using namespace std, int main, int m, n, cout into two numbers, cin, m, n, cout the remainder of m divided by n. Cout is m minus n divided by n times n, end L, return 0. Note that we displayed the message and the expression in separate cout statements simply because the line became very long. It would have been quite acceptable to place them all in a single cout statement. Type in the following program. Inputs a time and a number of hours. Calculates new time after number of hours as has elapsed. Hashtag include iostream using namespace std, int main, int time, hours, int time, cout to enter a number of hours, cin hours, cout in hours, hours the time will be, cout time and hours 24, end L, return 0. In your study book, draw a table with 4 columns and at least 10 or more rows. Label the columns time, hours, predicted, and actual. Now compile and run the program. Enter two numbers on the keyboard and write them down in the first 2 columns of the first row of the table. Before pressing enter after the second number, write down what you predict will be the output of the expression in the third column. Then press enter and write down what the computer actually outputs in the 4th column. Repeat this process a number of times until you can successfully predict what the output will be for any input and have worked out in general what the operator does. If you are not sure which numbers to test, take a peek at the subactivity solution below. We tried the following values for time and hours. Time and hours. Time hours predicted actual, time 0 hours 0, time 0 hours 13, time 0 hours 55, time 0 hours 24, time 23 hours 1, time 23 hours 5, time 12 hours 24, time 12 hours 48, time 12 hours 73, time 144 hours 144. The interesting results for this choice of input values were as follows. Row 3. A rather strange value was displayed. Row 4. This indicates that a wraparound is occurring. 24 hours after midnight, 0, is again midnight. Rows 5 and 6. Tests whether the idea of the wraparound is correct. Rows 7, 8, and 9. Tests whether the wraparound works for multiple days. Row 10. We used an illegal input for the first number to test whether the modulator operator works for any numbers. We know that 144 is a multiple of 24, as is 288. Hopefully you discovered in this exercise that the modulator operator gives the remainder. In other words, if we have two numbers, I and j, the expression I modulator operator, j gives the remainder of I divided by j. Note that every value that is output by the program, namely the value of the expression, is always a number from 0 to 23. This is because whatever the value of time plus hours is, when it's divided by 24, the only possible remainders are 0 up to 23. Discussion. The modulator operator is very useful in a number of interesting situations, so it is worthwhile spending some time making sure you understand what it does. As stated above, it gives the remainder of one number divided by another. Remember that this is with respect to integer division. Consider the following examples. 5 divided by 3 is 1, remainder 2. So 5 divided by 3 is 1, and 5. Modulator operator 3 is 2. 4 divided by 2 is 2, remainder 0. So 4 divided by 2 is 2, and 4 modulator operator 2 is 0. 3 divided by 6 is 0, remainder 3. So 3 divided by 6 is 0, and 3 modulator operator 6 is 3. 23 divided by 4 is 5, remainder 3. So 23 divided by 4 is 5. And 23 modulator operator 4 is 3. The second solution is calculate the remainder of one number divided by another. Include IO stream using namespace std. Int main. Int m, n. Cout. Enter two numbers. Cin, m, n. Cout. The remainder of m divided by n. Cout is m modulator operator n, l. Return 0. Important points in this lesson. Programming concepts. In this lesson, we have seen what a variable is, namely a memory position where a value is stored. A variable has a name so that we can refer to the memory position. To create a variable and give it a name, we use a declaration statement. The general format of a declaration statement is int variable name, where variable name is any sequence of alphanumeric characters or the underscore character, but that does not start with a numeric character. We can declare more than one variable in a declaration statement by listing them in the place of variable name and separating the names by commas. We also learned how to use a cin statement to input a value from the keyboard and store it in a variable. The general format of an input statement is cin variable name. We can input more than one value, in other words, get values for more than one variable, using a single cin statement. This is done by listing the variable names and separating them by the operator. We saw that the operator is used with cin, whereas this operator is used with cout. This cout statement can be used to output a mixture of string messages, variable values, and values of expressions. Expressions can contain one or more variables in the place of integer literals. Finally, we saw that the modulator operator can be used to calculate the remainder of one number divided by another. The remainder is always a number from 0 up to 1, less than the divisor. For example, n modulator operator 10 will always give a remainder of 0 up to 9, no matter what the value of n is. To sum up, if you think back to the lesson of 1, end of lesson 1, you will remember that we said that the general structure of a program is descriptive comment, include standard header file, using namespace std, int main, statement sequence. In this lesson, we have seen that there are other statements that can be included in statement sequence, namely declarations and cin statements. Programming principles. In general, we place declarations at the beginning of statement sequence, although we put declarations anywhere in the program. We must declare a variable before we can refer to it, however, and so it is best to declare all variables at the beginning of the program. Another aspect of good programming style is to use meaningful and descriptive variable names. We generally use lowercase letters for a variable name. However, if the name consists of more than one word, we use uppercase for the first letter of each subsequent word and join all the words together. However, if a variable is only used to store a number that doesn't represent some other amount, we prefer to use a single letter of the alphabet, normally M or N or I, J, or K. Exercises 3.1. Write a program that inputs 3 values and displays them on a single line in reverse order. Exercise 3.2. Look at the following program and then answer the questions that follow without typing in the program and testing it. Include iostream, using namespace std, int main, int xyz, cout, enter values for variables x, y, and z, end l, cin, x, y, z. Cout, x plus y divided by z is x plus y divided by z in L. Cout, x modulator operator z is x modulator operator z in L. Cout, y times z divided by x plus 2 is y times z divided by x plus 2 in L. Return 0. What will the output be if the user enters 2, 6, and 4? What will the output be if the user enters 5, 1, 3? If the last output statement is changed to cout, y times z divided by x plus 2 is y times z divided by x plus 2 in L. What will the output of the statement be if the user enters the same values as specified in I, in number 1 and number 2? Exercise 3.3. Lorraine inherited her grandmother's old cookbook, but all the oven temperatures are given in Fahrenheit, and her oven is only calibrated in Celsius. Write a program to help her. The formula for converting from Fahrenheit to Celsius is C is equal to 5 times F minus 32 brackets divided by 9.